Let's see the next point, median. The segment joining the vertex and the midpoint of opposite side is called median of triangle. See here in this figure, this triangle ABC. Here AC, first measure the AC. This is the 7 centimeter. If AC is 7 centimeter, then find out the AD. AD is 3.5 centimeter. This AD is 3.5, DC is 3.5 and AC is total 7 centimeter. It means this AD and DC is the half of AC. It means the point D is the midpoint of AC. And as per the definition, the segment joining the vertex and this midpoint is called a median. So here in triangle ABC, segment BD is a median. On the base AC. If you draw, see here the triangle ABC, and if you draw the median of from the all vertex, let's see here, R is a midpoint of BC, so AR is a median, Q is a midpoint of AC, so BQ is a median, and R is a midpoint of AB, so here CP is also median. The medians are concurrent. Their points of concurrence is called centroid and it is denoted by G. Point of concurrence of median is called centroid and it is denoted by G. And for all type of triangles, the location of G is in the interior of the triangle. The centroid divides each median in the ratio 2:1. It means AG is to GR is equal to 2:1. Then BG is to QR, BG is to QG is equal to 2:1 and CG is to GP is equal to 2:1. These ratios of this centroid divides the median in the ratios 2:1 means AG is a double of GR, BG is a double of QG and CG is a double of GP. Okay, it means this GP is 1, then CG is 2, GR is 1, then AG is 2, BG is 2, then GQ is 1. It's divided in the ratio 2:1. Now let's see how to draw the altitudes and medians.
The altitudes of an acute angled triangle. The height of the triangle is the perpendicular distance from any vertex to its opposite side. In the triangle ABC, AD is the perpendicular distance from the vertex A to its opposite side BC. Then AD is the height of the triangle. Draw the altitudes of triangle ABC. 1. Fix the ruler on one of the triangle's sides, say it is BC. 2. Put the edge of one side of the right angle of a set square on the edge of the ruler. 3. Move the set square along the edge of the ruler until the vertex A coincides with the edge of the set square. 4. Draw the line segment AD so AD is perpendicular on BC, then AD is the required height. One. Fix the ruler on one of the triangle's side AC. 2. Put the set square on the edge of the ruler to coincide with side AC. 3. Move the set square until the point B coincides with the edge of the set square. 4. Draw the line segment BE. BE perpendicular to AC, then BE is the required height. To draw the third height CF from the vertex C to the opposite side AB, we repeat the previous steps. CF is the third height of triangle ABC. In the acute triangle, the three heights intersect at one point inside it. The heights AD, BE, and CF intersect at the point X inside the triangle.
The centroid of a triangle is the point where the medians of the triangle intersect. The median of a triangle is a segment extending from a vertex to the midpoint of the opposite side. In order to construct the median from this vertex to this side, I'm going to need to know the midpoint of this side. And the only way that I can find that is by constructing the perpendicular bisector. Remember that when we construct the perpendicular bisector, we need to make sure that our compass is open over halfway between the two endpoints of the segment. Then what we do is we draw an arc below and above each of those endpoints. Now I use a ruler to connect those intersections. I'm going to draw this with a dotted line because it's not really the perpendicular line that I'm interested in. I'm just interested in this point right here because this is the midpoint. Now I'll do it for the other two sides as well. Now you may notice that these three perpendicular bisectors all intersect at this point, and this point is called the circumcenter. But the circumcenter isn't really what this video is about. It's a byproduct of constructing the perpendicular bisectors, but what we are really interested in are the three midpoints, here, here, and here. So now let's use our straight edge and construct our medians. Here's our first median. I'm going to use a thicker line just so that we can clearly see what the medians are and not get them confused with all of the other marks on the construction. Notice that I have gone from the vertex to the midpoint of the opposite side. And now I will draw the other two. All three of the medians intersect right here at a point that we call the centroid. The centroid will always be in the interior of the triangle.